Within Christianity, a lot of times you say, oh, it's just a local flood in the Tigris-Euphrates Valley in the Middle East. Well, actually, there's powerful evidence. If we open our eyes, we got to use our flood glasses to look at it. And you know something? You see it all over the place. Now, I've been in the creation evolution issue for about 30 years, and I've focused on earth sciences. You know, you can divide up the origins issue into the evolutionary assumptions, assumption A, and the creation assumptions, assumption B, and we use the same facts generally. I mean, there's some exceptions of this, the rocks and the fossils. And you know, with those different assumptions, we get totally different interpretations. It's where your worldview is. It's where your mind is. It's where your heart is that counts. Now, my focus has been on to use the assumptions, the biblical assumptions and science, and using the data, and to answer or try to answer challenges that the evolutionists has given us. That's been my challenge. Like, what about the ice age? What about rocks, fossils? How do they get there? That's been my focus, not necessarily to bash evolution, which is really easy to do. It really is. I was amazed how easy it is to do. And of course, Mike and Tom have done a good job at doing that. So I'm going to look at the rocks and fossils, and actually I'm not going to look at too many of them, but it's which bias we're talking about. Which interpretation? Either the Bible is true or the Bible is not true, using mostly the same evidence. I must put a caveat on that because I go out in the field all the time looking at the rocks, and a lot of times it's what they don't report in the scientific literature in geology that's very key. So we go out and we see things out there that they don't report that is very key to the interpretation. First of all, it's a global flood. Now, I start with the Bible first and science second. And so when I grew up in what many would consider a liberal church, I wouldn't necessarily use that term, and I was taught, you know, there's errors in the Bible and the whole shot, so I had to check it out for myself. And I found that in the Bible, the evidence for a global flood wins hands down. The context, destroy all mankind. And by the way, why did God do this? Was it because he was mean and nasty? No, he says the evil was in man's thoughts continually. Man was thinking of evil continually. It must have been a horrible situation, so he had no choice. The ark landed in the mountains. Now, I'm a meteorologist. Actually, I'm the best type of meteorologist there are. That's a weather guesser for short. The best type is a retired weather guesser, and that's what I am. And I'm no longer to blame for ruining hundreds and thousands of picnics and all that outdoor activity. But anyway, when water dumps and you have a flood, anybody in a boat and like that is going to go downstream or end up in the ocean if you go far enough. They're not going to end up in the mountains. Well, the ark landed in the mountains of Ararat. That's what happened if the waters were global and they just descended, dropped like that. And the first place the boat is going to land is on the highest terrain that shows up, and that's going to be the mountains. Makes a lot of sense. And why have all those animals on the ark if it's just a local flood? I mean, they could flee to the Zagros Mountains, which are pretty close to the Middle East, which are up to 15,000 feet high. And a 371-day flood is hardly local. I've forecasted a number of floods, flash floods, river floods, and they're over with in usually a day or even sometimes an hour. 371-day flood is hardly local. So the Scripture indicates that it was a global flood. And the covenant of the rainbow would make no sense if it was a local flood, because there's been hundreds of thousands of local floods since. Like Genesis 7:9, as far as context, says, and the waters prevailed more and more upon the earth, so that all the high mountains everywhere under the heavens were covered. Now, doesn't that sound like a universal global flood? And just think of this. Look at the upper left in there. Look at that beautiful rainbow. It's a promise from God that he'll never again flood the entire earth as he did in Noah's day. Well, my Christian college professor said that Noah's flood didn't cover the entire earth. He told you it was just a localized flood? That's what he said. Look at the bottom right. So he believes that God promised to never again send a localized flood? See, it doesn't make sense, does it, that it's a local flood? And of course, Jesus. Now that's where the buck should stop. Jesus says, for in those days which were before the flood, they were eating and drinking, they were marrying and giving in marriage, until the day that Noah entered the ark. Jesus believed that Noah was a real person, the ark was a real person. I mean, the ark was a real boat. Hey, I'm a morning person. And I fade in the evening, so if I trip over my words, forgive me, please. And they did not understand until the flood came and took them all away. Just a few of them? In the Tigris-Euphrates Valley, in the local flood? No, all of them. Anyway, now if you're thinking of a flood, I'm using a man named Tasman Walker from Australia. He developed a terminology or a model of the flood just from Scripture. What would you expect from the flood? Well, it would rise and it would fall. I mean, that's what floods do, right? And of course, we don't know what the pre-flood geography was like. In fact, it was probably totally ripped up and destroyed. But in general, the relative sea level is like this, and the time in the flood is this way. By the way, the flood was 371 days, not 40 days. But if you had to draw the sequence of the flood, it would be a rise with sea level going up and down in a general rise. That's what that squiggly line means. It's not because I can't draw, which is actually a true statement, but it's because I deliberately did that. Because sea level, because of tectonics and other forces, would be going up and down like this in a general rise. Then it'll peak about 150 days. Now, there's some people that think that it peaked at 40 days. It's, you know, a difference of opinion, and there's no way to resolve it. But at 150 days, it starts to flow off the earth, and the present continents become exposed. That's what we expect in a flood. Now, you can split that up into the flooding stage for the first 150 days and the retreating stage. Now, I'm only going to focus in on the retreating stage because that was the last stage of the flood as it came off the land. So we should see the evidence of the retreating waters off the land if the flood was a real event. This gets into the geological field of what's called geomorphology. Remember that big word that Mike gave you called morphology? Shape means shape. Geo means earth. It's the shape of the earth. And the shape of the earth, features of the earth's surface, should say flood. And the alternative explanation, uniformitarianism, which is the present is the key to the past, should have a lot of difficulty explaining these things. So that's what I'm going to focus in on. And you can divide that up into two phases. The water moving off the land as a sheet and then moving off in channels. Now why channels and the sheet? Because when the earth is totally flooded and you only have maybe one mountain up, Mount Ararat, you know, the water's moving around the earth maybe in currents 1,000 miles wide. So it's moving sort of as a sheet. Not very deep, maybe it's 1,000 feet deep, but it's 1,000 miles wide. It's moving across the earth like that. And it produces certain features on the earth's surface. But then when you got mountains and plateaus sticking up, you know, the water's forced to flow around these obstacles. And therefore it forms channel. It's the channelized phase. So there's two phases. Water moves as a sheet, then it's forced to become more channelized. And it's important to point this out because features on the Earth's surface give evidence of both phases. So I'm going to talk about, especially about water moving as sheets. Most of my talk is going to be about the evidence of the water moving off the continents as sheets. It causes rapid erosion of the continents. See, the continents are rising, the water's moving off. It's going to erode those continents. And then where's the material going to go? It's going to end up along the edge of the continents in deeper water. And what is it going to do? It's going to plane land, forming what's called planation surfaces. And I'm going to go through all this. This is a summary of my talk right here. But this is, I'm going to also talk about this. As it's moving in channels, it's going to cut what is called water and wind gaps. A typical water gap around here is the Columbia Gorge. It's a cut in the mountains that's perpendicular to it. That's a water gap, to where water is flowing through it. I don't think I'm going to get into wind gaps. That's a gap higher in the mountains where you have a V notch out and only wind is going through that. I don't think I'll have time, but I have pictures for all these. Also, it forms what's called pediments. A pediment means near, and ment means mountain. So it's a flat planation surface at the foot of a mountain. And it excavates submarine canyons, all very rapidly. Submarine canyons are canyons that you go out on the continental shelf, and perpendicular to the continent, you have this deep gash that goes about an average of 3,000 feet deep and 50 miles long is the average submarine canyon. Now, there are hundreds of submarine canyons along the continents. And some of these canyons are deeper than Grand Canyon. And one of them is even longer than Grand Canyon. It's the Bering Canyon. Now, if you did a present-day erosion of the surface for 5,000 years in various reliefs, mountains to smooth plains and high precipitation, this is the rate currently. 7 feet in 5,000 years, and the lowest is down in here, less than a foot. This, of course, there have been ice ages, which I'll talk about tomorrow about ice ages. If you think this air conditioning is cold in here, wait till I talk to you about the ice age tomorrow. Hope to freeze you out. But anyway, the point of this is that the flood was about 5,000 years ago. So this is not a lot of erosion. So what the flood produced should still be there. It didn't have time to erode in 5,000 years because we've had very little erosion in 5,000 years. That's the point of that. So the first question to ask when you have a totally globally flooded Earth, how did the waters drain? Where did they go? Well, I think Psalm 104, 6-9 has the answer. It's really interesting how in some cases it's right there, right in the Bible. Psalm 104 says, "The waters were standing above the mountains. At thy rebuke they fled. The mountains rose, the valley sank down." That's the key verse right there. The mountains rose, the valley sank down to the place which thou didst establish for them. Thou didst set a boundary that they may not pass over, that they may not return to cover the earth. There are 2 times in the history of the earth that the earth was totally flooded. On the 3rd day of creation, when it was created with covering of water, and in the global flood. This obviously is talking about the global flood because this is the last time that the earth was totally flooded. But at thy rebuke the waters fled, and at that time the mountains rose, the valleys sank down. That's how they drain. In other words, mountains rise, valleys sink down, and then at the same time continents rise and ocean basins sink. So the waters flow off the continents into the ocean basins. Like this. This is the Continental Divide here in western Montana. And it's uplifting. It's probably the first area to get up, to come out of the floodwaters. And the water is flowing strongly towards the Pacific Ocean on the west side and strongly towards the Mississippi River Valley on the east. That's the picture I want to present. Now, it's interesting that you can go to many mountainous areas or many places of the earth, in fact, practically all places of the earth, and it's a theme that you have sections of the crust that have gone up and sections that have gone down. Now, where I live, in southwest Montana, I'm close to what's called the Beartooth Mountains right here. Now, they're about 10,000 to 13,000 feet tall, and that's granite. That pattern is granite. But you go to the adjacent Bighorn Basin, and it's filled with sediments. But granite, where you reach granite in there, is at 10,000 feet below sea level. So at this point right in here, what's called the Beartooth Fault, you had a differential change where the mountains went up and this valley or basin went down, and a 23,000 foot difference right here at the Beartooth Mountains. Over on the other side of the Bighorn Mountains, you have another situation with the Bighorn Mountains and the Powder River Basin. In fact, most little mountain ranges east of the Continental Divide are like this, that where you have mountains rise and valleys sink down. This is a theme, a global theme, just like Psalm 104 says. And I think it was also a theme on a larger scale, where the continents were coming up out of the floodwaters and the ocean basins sinking. Like this. After the flood, you had the continents with its mountain ranges and basins right in there, and they had the ocean basins sink. Now, is there any evidence for such a thing? Well, in a recent book by Oard and Payne, The Origin of Mountains, they said that most mountains look fresh, as if they're recently formed. In this book, it shows that mountains are not made directly by folding, but the result of vertical uplift of planes. In other words, mountains are formed from vertical uplift of planes. They think they were planed first, and then they came up, and then they eroded to form, which may later be eroded into rugged mountains. It also assembles the evidence that this uplift occurred in the last few million years. Now, I'm quoting evolutionists, and when they say the last few million years, that is the very end of their time scale, meaning they're recent. You know, and to them, they automatically say, oh, a few million years, and not 100 million, not a billion, indicating the mountains are recent because they're very fresh looking, except the Appalachians and a few mountains like that, of course. Also, is there evidence that the ocean basins have sunk? Yes, there is, in the form of guyos. On the bottom of the ocean, we have at least 50,000 what's called seamounts. They're mostly submarine volcanoes. But there's well over 1,000 of these called guyos that are truncated flat. In order to do that, it has to be at sea level and probably pretty fast currents, probably during the flood. I'm not sure sea level today can do that. But the interesting thing about these flat guyos that were at sea level is that they're an average of 5,000 feet below sea level now, indicating that the bottom of the ocean has sunk an average of 5,000 feet. Now I'm going to quote my favorite geomorphologist, Lester King. He's an evolutionist, and I'd say for an evolutionist, he's a pretty independent thinker. And here's what he says about guyos. Marine volcanic islands, which have been truncated by the waves and since subsided below sea level, are called guyos. Most of them seem to have sunk by 600 to 2,000 meters. That's the translation into feet, multiplied approximately by 3. And it is evident that they afford a measure of the amount by which the ocean floor has sunk in later geological time. Notice that, later geological time. It's one of the last events in their geological time, is the ocean basin sinking. Now, well, that's exactly what we expect to drain the floodwaters, the ocean basin sinking. The Pacific floor especially has subsided. All the ocean basins afford evidence of subsidence amounting to hundreds and even thousands of meters in areas far from land. So the fundamental tectonic, now tectonics is a vertical motions of the earth crust. The fundamental, notice that, fundamental tectonic mechanism of global geology are vertical. That's up or down. And the normal and most general tectonic structures in the crust are also vertically disposed. But one must bear in mind that every part of the globe, on the continents and in the ocean basins, this is a theme in the bottom of the oceans too, by the way, called abyssal hills and abyssal plains. The plains are flat because they've been filled with sediments, but they're valleys. They're valleys. So you have this mountains and valley going up, valleys sinking, even on the ocean bottom. It provides direct geological evidence. Notice that, direct geological evidence, not speculation, direct geological evidence that formerly it stood at different levels, up or down, and that it has been subject to in situ to vertical displacements. Excuse me about this mix-up here. My computer, I'm not using my computer, and I don't know why it's combining those, but anyway, it's doing it. So what he's saying is, to translate that, is that what we see now was at different levels, either up or down, and that all over the earth, in later geological periods, we have evidence of the crust going up or down. What powerful evidence is Psalm 104 that speaks of the drainage of the floodwaters. It's powerful evidence. So, as the continents were rising up and the water was coming off, you'd expect a lot of erosion as a sheet, when it's moving as a sheet flow. Is there evidence of rapid sheet erosion? Actually, if you travel around the western U.S., you see a fair amount of it. Most of these slides I'm going to show are from Montana and Wyoming, and some in Canada, generally close to the Continental Divide. But you have these what's called erosional remnants. Devil's Tower. How many have been to Devil's Tower, northeast Wyoming? Isn't it rather odd to have that throat going up 800 feet high from this point right here and 1,200 feet above the river, just real thin? And And then you see a road sign next to it that says that, well, this is the throat of a volcano, and these sedimentary rocks around here had to be at least over this volcano here. And they eroded down slowly over millions of years, 70 million years or so. And yet, that thin Devil's Tower hardly got touched in 70 million years. Now, Phillip Johnson, he's the, you might say, the head of the intelligent design movement, says we need to put on our baloney detectors when they make statements like this. Now, we know that erosion is slow, but over millions of years it's fast. In fact, at the present rate of erosion, all of North America would erode to sea level in just 10 million years at the present rate. But as the mountains wear down, the rate will increase. So it's not that simple, but it's over 10, maybe up to 50 million years, North America is down to sea level. And yet, in that amount of time, actually more than that time, Devil's Tower just sits there, hardly eroding. And look at those joints. That's like a basalt. And, you know, how many have heard of freeze-thaw weathering, where you get water in a crack, and the freezing, I mean, this is right in my field of meteorology, because it splits it apart. That would be a pile of rubble probably in, I'd say, 50,000 years. It should be a pile of rubble. But yet they say it's been like that for 50 to 70 million years without hardly being touched, while all the plains around it eroded down to nearly a flat surface. Doesn't make sense. But there's more erosional remnants around. How many have been to Monument Valley? I mean, it's sandstone and shale. That sandstone is not very hard. You can go up there and just rub it off, flake it off. It's very soft. Why would all this area erode to a flat surface and leave these 1,000-foot remnants here? You know, it doesn't make sense by the properties of erosion that they should be there. The way you can explain all these is if a sheet, you see this in the channeled scablands with the Lake Missoula flood, if a sheet of water came and eroded most of it, but it leaves some of the more resistant remnants, or maybe because the currents were a little slower in that one spot, it leaves some erosional remnants in a flood. That's what you'd expect in a giant flood, as a sheet flow, leaving a few erosional remnants. There's another throat of a volcano, Shiprock, northwest New Mexico, 1,700 feet. And all this area around it eroded away. See, the plains right in here had to be above this, and it all had to erode down to what you see, leaving 1,700-foot throat of a volcano hardly touched in millions of years. Put on your baloney detectors when you drive around, and you see a lot of geological features that don't make sense, but it's powerful evidence of the sheet erosion off the continent during the Genesis flood. Another thing, that quartzite rocks. Now, this is a research project I've been involved in for about 12 years. Quartzite is a metamorphic sandstone, and that's sand that's turned to stone, and then a little heat is added to the sandstone, and it kind of becomes a little glassy because, you know, sand is mostly silicon dioxide, like the windows up there. And when it does that, it becomes very hard, and it's resistant to erosion. And the Rocky Mountains are loaded with quartzite rocks, but there's hardly any of them on either side of the Rocky Mountains. Like there's hardly any in Washington and Oregon. In fact, I think only in extreme northeast Washington do you find quartzites. But I find these quartzite rocks spread hundreds of miles into North Dakota, Montana, Saskatchewan, Alberta, Wyoming, and on the other side I find them in Washington and Oregon. In fact, I have found them in the Puget Sound area where the glaciers have mixed them up. Well-rounded quartzite rocks, rounded by water. And the thing about it is that you can calculate, well, how fast of a current do we need to spread these quartzites from the point of the Rocky Mountains far, hundreds of miles from the nearest source? Well, we did those calculations. But first of all, let me show you some exotic places for quartzites. We find them on tops of mountains, by the way. Mountains that don't outcrop any quartzite, but we have the rounded quartzite rocks on these. Like here's the Wallowa Mountains in northeast Oregon. See these rounded rocks by water? This is on a ridge at near Lookout Mountain, 8,200 feet in the Wallowa Mountains. In fact, there's one of the quartzites, well-rounded by water action. That rock weighs 400 pounds. Now, what kind of currents are going to transport that? The nearest source is 60 miles to the east in Idaho, across Hell's Canyon, I might add. So how are you going to get these rounded rocks? And by the way, in these finer sediments in here, there's gold, because the current was so fast, the gold wouldn't settle out. It got mixed. So we're talking about powerful currents. And then the mountains came up and carried the quartzites to the tops of mountains. There's 4 mountains areas that we find that these rocks like this. The Wallowa Mountains. There's the mountains in Central Oregon. We found them last year in the top of the Blue Mountains. I found them in the top of a mountain range in southwest Montana called the Gravelly Range. And this summer, I'm going to hike up into the northern Tetons. And there's one of the Tetons that's been sheared off, planed. And we find rounded rocks on the top of that. I'm going to find, that's one of, I found them on 3. I'm going to check the 4th one. But anyway, the tracing of these things, and I'm going to get into this a little later, indicates powerful evidence for the flood. But first of all, I got to switch themes. As the water's moving as a sheet over the continents and eroding the continents, where's all the debris going? I mean, you erode something and you transport it, it's got to be deposited somewhere. Where it's going to be deposited where the currents slow down. This we observe in normal floods today. Well, where's that? Well, it's where the water becomes deeper, is where the currents will be forced to slow down, and that's at the edge of the continents. And that's the continental shelves. It's like a bathtub ring, about 200 feet deep on the average, all around the continents. Every continent, even small, I should say medium-sized islands, have a continental shelf. Now, the continental shelf is a strange profile when you consider normal processes over millions of years, because it's very shallow, goes out for miles and miles, and suddenly you have a big drop-off like this called the Continental Slope, and it continues to the Continental Rise and to the Bissell Planes, which is the very deep ocean. And some of these are hundreds of miles long. Now, this nature should have more of a profile that's gradually